Hey, what's going on, everybody? It is your boy Jay Bailey here, and I'm back with yet another video. And as you can see, I'm trying something a little bit different here. I got my face in the box here. If you don't like it, or if it's just too distracting, let me know. It will be gone the next video. But I just want to try this out and see how it looks and see how it works. And let's go ahead and get started here. So this one is called Can You See Me? And it wasn't particularly hard, this challenge, but it was a little bit confusing. There was some parts that kind of pissed me off that I was like, I was getting lost. But I think it was just more stupidity on my part than anything. But let's go ahead and look at this guy. I thought this was a fun challenge, so thank you for recommending it. And we see here that there's this is a 32-bit binary, and we also see that it's not stripped. And so all the 32-bit binary means is that we can the functions the parameters are going to be passed on the stack but instead of in registers. Okay. And so I'll point that out when we look at this in ghidra. I'll be using ghidra, by the way, so don't get too upset. I'll show you why I'm not using IDA. And we're going to be using, we see here this is random function, and we see here that doesn't have this @glibc here. And so what I believe that means is the author defined a random function, and so hopefully the author didn't do like something crazy, but we'll find out later on. We also see so we have a user defined. And we also see that there's a seed value, and it's in the this big D section here. Big D. and all that means is that it's in the data section, and that means it's been initialized to some value. So we have a static seed, which is good for us because that means it should be deterministic, right? So the random function should produce the same values every time the program is run. So that makes things a little bit easier for us. And then we see that there's a visited variable, which is also a global variable, but it's not been initialized because it's in the BSS segment. And with that, and so when we run the program, the visit is going to be set to 0 initially. Okay, so that's just how it is. When it's in the BSS segment, when you run it, it gets set to 0. So recall that because that's going to be important later on. And then here we have this Xflag variable, and so we have visited and then Xflag, which is most likely going to be our encrypted flag. And we also see that if that's in the what is it? It's in the data section as well. And so that means we can look at it right away. And I'll show you really quickly. So if we use object dump -s, that's going to print all the things in this section that we're going to choose, and -j actually chooses this section, which is a little bit counterintuitive to me, but it is what it is. And so we look at here 804.8040. That's right here. So this is going to be our encrypted flag here. And so we have, the way you have to read it is backwards, right? So we 0804 8630. And the reason why I did that is because remember this is a little endian, so we had to read things in reverse order. I'll just get rid of this trailing 0 or leading 0. And when we look at the seed as well, we see the seed is actually going to be over here. So if we count, this is 90. This is 91, 92, 93, 4, 5, 6, 7, and this will be 98. All right, so all this here is going to be our seed, and 0 hex 03, 04, 33, E9. So that's our seed there. All right, so we know what that is off the top. So that's good. And let's go ahead and run strings. And so you would think that because this is the Xflag is actually in the data section, we should be able to see in the strings because it's been initialized to something, but we don't see anything that will be indicative of it. But we do see our good job here. We do see our our error messages here, and we see this big chunk of space, and we don't really know what that is yet, but we will later on. And let's go ahead. I'm going to open this up in IDA really quickly, and I'm going to show you why I'm not going to use IDA for this challenge. So if anybody has any ideas of how I can fix this, I'm pretty sure it's a simple issue, but I just couldn't figure out how to do it. So when you look at this here, this here is a variable. This is another variable here, and another variable. And I like to rename all my variables, but I couldn't do that for some reason. And I don't know if it's an IDA thing. I don't know why it didn't let me rename these variables, but I couldn't do it. So if you know how I can do that, please let me know, because I would love to know. And so that's why I'm not going to be using IDA today. I'll be using ghidra. So let's go ahead and pull that up. Ghidra. Alright, so Control N to start a new project and hit next, and then I'm gonna give it a name. Can you see me? And then we're gonna import with hit the I key on your keyboard and just select File to import. And hit OK. And hit OK. And then double click. Yes, so I want to analyze. I'm still using the default options here. I haven't changed that. And alright, so that's done. Let's go ahead and go to the main function. Alright, and so here we have, this is going to be comparing the argc here, because alright, this is param1, and obviously param1 is for the main function is argc. So we're comparing that to 4. Whoops, sorry about that. So that's pretty much going to be if argc is not equal to 4, then we're going to do print error message and exit. Alright, so I'm going to go ahead and rename this guy here to argc. And so renamed variables and Ghidra is a little bit different from IDA. You press the L key on your keyboard and it'll rename the allow you to rename the variable. And so if we do give it 4 parameters, we jump down here and we have here, this is argv, which is param2, right? All right, we'll put that into EAX, and here is we saw something like this before, right? So this is obviously going to be getting the third argument of argv. And how I know it's the third one, I'll just show you really quickly. We have argv plus 4, argv plus 8, and then argv plus xc. So this would be argv sub 0, 1, 2, and 3. So this is argv sub 3 here. I think I said 4 earlier. I was wrong about that, so I apologize. So we store that into the EX register, and then we see it down here, and my mouse is acting up again. I apologize, this mouse is trash. I will upgrade soon. So we're gonna hit the L key on our keyboard here to rename this guy. That's gonna be our user input. And so up here, user input equals to argv sub 3. All right. Okay, so then we see we load this in the EX register, and then we load this into ESP. And notice it's in the square brackets, and so what that means is we're not gonna change the address, but the address points to something, and we're gonna put EAX where ESP points to. Okay, and then we're going to call strlen, and it's going to get the parameter from ESP, right? And so then when it returns, it compared to text 16. So obviously we have if strlen user input is not equal to let's say equal to 16. We're going to do some things. Actually, is it not equal to or is it equal to? Come on, mouse. All right, yeah. So if it starts not equal to, we're going to print error message and exit. All right. Okay. Yeah. And then we're gonna jump down here, and we see here we're gonna load 0 into these two values here, and so I'm gonna rename these to I and J respectively. And so then we have I equals 0, J equals 0. All right, and so we jumped. Where the heck did I jump to? Oh, yeah, sorry, we jumped right here. Sorry, right here. And we see we're going to compare J to hex 21986D. And I don't know why it's comparing to this really, really big number. I have a theory, but I haven't confirmed it yet. But I'm almost certain I'm right. I probably did something wrong in my own testing when I was trying to figure out why they're using this big number. But my theory, I think it makes sense to me, but I just couldn't quite get it correct. Anyways, I'll let you in on that little tidbit later on. And we see it compares it to hex 219A6D, and if less than or equal to, we come back up here, and we see that we're going to call this random function. And ghidra is actually nice enough to tell us that it returns a long and it has a void parameter. And so we see here, this is obviously going to be our return value there. So we're going to do random number equals to that. And I'm going to assume right now it's going to return 10, and I'm saying 10 because that's my favorite number. And I'm not going to look at the random function just yet. I want to save that until later on in the video. But we're just going to assume right now it just returns 10 because I like 10. And let's go ahead and rename this guy here. All right, and so then we have start that to EAX, and we add that to visited. And let's see. So then that's going to look like visited sub random number here, right? And then we get the actual value, right? Because it's in square brackets. We get the value at that address. So we're going to get 0. Because remember I said it's going to be 0 all the time. It's going to place that into EX register, right? So, and then what happens? It has this test ALAL, and this instruction always used to confuse me. But all this is going to do is it's going to perform a bitwise AND on the AL register, right? So AL is equal to 0 because EX is 0, and it's just the lower 8 bits of it. So it's going to take that. It's going to do 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, and then if we do a bitwise AND, we just get all zeros again. So this is essentially testing if visited sub random number equals to 0, right? And so obviously if this was 1 here, then this would be 1. Oops. This will be 1, right? And because 1 and 1 is 1. And yeah, so that's all this is doing, is checking whether or not this is going to be 0. And if it is 0, we're going to continue on with the executing our stuff. If not, come on mouse. If not, we're going to jump down here and continue the loop. But let's go ahead and go back up here. All right. Actually, I'll just add that in here right now. J++. All right, so let's see what it's doing here. So we get random number, put that into the EX register, and then we get visited as a random number again. And this is a little bit confusing. I don't know why ghidra is displaying it like this, but if you press Ctrl-Shift-G on your keyboard, it's going to allow you to actually patch the instruction. We're not going to patch it here, but it's going to show us what that instruction should be. So we see here it's going to put 1 into the value of a visited sub random number, right? So essentially we're going to say visited sub random number equals to 1. And now it may be obvious what this thing is trying to do. It's essentially trying to, if we visited this one before, we don't want to continue doing whatever it is this function is going to do, right? And so we can actually take a look at visited here, and we see that it's actually 22 bytes long. And if you think about it, it checked earlier if we gave it 22, right? So hex 16 is 22, and so it essentially checking to see if we give it the right length, because it's going to do our flag is 22 bytes long. And so let's go ahead and continue here. And so then you see right here we have random number, load that into EDX, user input, put that into EAX, and essentially user input to random number. And we're getting the actual value again and putting that into EAX, right? So we have, I'm going to say user EAX equals to user input sub random number. And let's assume right now we gave it like A, or user inputs random, or user inputs a random number. Let's just assume it was A, and so it's going to hold hex 65 in there. Okay, remember that's going to be important. And so then, okay, so then we load that into EBX. So actually, so EBX equals to EAX, which again is just this. All right, and then we put ESP plus I, which is the I variable, into the EAX, and so EAX now equals to I. And remember, right now it's 0. Okay, and then we do LEA, EDX, EX plus 1. So this is a little bit misleading. So LEA isn't going to actually mess with like memory, what it's going to do is it's going to interpret EAX plus 1 and store that into the EDX register. Okay, and so right now, so that's what that's going to look like. EDX equals to EAX plus 0x1, which is essentially I plus 0x1. Okay, and then we set I to DL, which is essentially EAX plus 0x1, which is again essentially I plus 0x1. Right? Okay, so that's what that is. And then it gets a little bit confusing here. So we take AL, and we move that into EX register. We kind of extend it so it fits into 32 bits register. And then we use that for our index here. So we have Xflag sub EAX times 0x4. And that's going to be put into the EAX register there. And if you remember, EAX is equal to I, but it's equal to the I before we did the I plus 1. So it's actually going to be, so this right here, this I plus 1 happens after we actually index our Xflag variable. Okay, so this is Xflag sub I times 0x4. I'm going to move this one down here to after we index it. Let's go ahead and delete. All right. Okay. And then we see that we put that into the ESP, and then we call Sterling. So I'm going to do a little bit of renaming here. So I'm just going to say Xflag sub I. I'll just call this flag, and then EBX sub user random number. We're going to call this character, right? So then what we're going to do here is we're going to compare EBX to the length of our flag, right? So that sounds kind of weird. So essentially we have character equals to X Sterling of X flag. Oh, I guess I just hit Sterling a flag there, right? That's what I did. And I guess that be equals to 0. Maybe not equal to 0. Then we break. I'll just say print error message and continue. All right, and so yeah, so, and you may think that this is weird, right? It doesn't make much sense, but let me show you what Xflag is. So if I go here, if I go to Xflag, and you see that, remember it's actually an array, a really, really big array here, okay? And we see that there are these addresses here, right? And these all have point to something. So if I double click on, on this guy here, we see that it's actually a really big string. And but it's all spaces. And remember, there was a whole bunch of spaces earlier on in the program, right? When we ran strings, we saw a whole bunch of spaces. Well, this here, if I keep on scrolling, eventually we reach a point where we reach some null bytes, right? So this is a null terminated string. So if we take the length of this string, right, it's going to, let's just say the length of the string was hex 65. If we take the length of that and we compare that to our character which we provided, which is hex 65, they're gonna be equal to each other. So that's what the author is doing. He's comparing our letters to the lengths of strings that correspond to ASCII characters. Let me break it down a little bit more. Hold on. So hold on. I know that it may sound confusing because it threw me for a loop. I'm telling you. Watch this. I'm gonna open up GDB. Actually, first thing I'm gonna do is I'm gonna do this. I'm gonna copy this here. All right. So I'm gonna open up GDB. And I'm going to, what am I gonna do? Oh, examine memory 22 WX and remember I'm using 22 because our visited is 22 bytes long, so I'm assuming our flag has to be 22 as well. So if we go here, we see that this X flag points to all of these different what are these called, addresses here. So if we could take a look at these, right? So if we can examine as a string, and then we're going to give it this address here. We see that it's the space character 100 times. Okay, so what the heck does that even mean? Let me show you really quickly. GD. Oh, sorry. All right. So Xflag sub 0 holds the value of 100 spaces, right? And Xflag sub 1 has 115. This is 102. And what I did was I mapped the spaces in here, the values in here to actual ASCII letters, and you can see here they map to ASCII letters here, right? Or ASCII characters, so D, S, F, D, underscore, etc., etc. So I did that for all of these, right? So I repeated this step that I did down here, where I was examining the string. I did for all of these things here. I'm sure that's an easier way to do it. I don't know how to do it, but this is how I was able to get these values here. And you may be wondering, like, what the heck are these numbers here? They look random, but they're not random. Let me show you really quickly, right? So if I were to go to, let's see if I can go back again. Alrighty. Let's go ahead and look at the random function here. And the random function, this part here is pretty easy, right? All it's doing. Let me go ahead and get our sudo C running up here. All right, so all this thing is going to do is going to take our seed and plus equals 1. That's all that's doing, right? So you see here we're getting the value of seed, which is hex, whatever it was, I forgot what it was. Put that into EAX, add 1 to that, and put that back into seed, right? And then we're gonna, and then so this part right here, this is where I actually didn't need a decompiler because I couldn't do my sudo C on this nonsense here. This was too much of a beast. So Control E to decompile, and as you can see, it's going to give us C times hex 49 mod hex 16. Okay. So return seed times hex 49 mod hex 16. All right. So that's our seed there. Okay. And so now how did I get those values in, right? So what I did was, and you might be able to guess what I did already. You already know I like to use Python for a lot of things. So I wrote this simple Python script. I put the seed in there, right here, and then I pretty much did the loop from 0 to 22, and I did seed plus equals 1, seed times this, pretty much the loop, right? And I printed it out. And if you can see here, random, it's going to correspond to these values here, 8, 15, 0, 7, etc., etc. So what does that mean? That means it's going to take, let's see, so it's going to take our user input sub 8 for the first one and compare that to Xflag sub 0. Okay, I know that sounds crazy, but that's what it's doing. So it's going to compare our 8th character that we give it. So we gave it, like, I don't know, password. It's going to compare that sub 8 with Xflag sub 0. Okay, and so now in order to actually solve this, what I did was, and there may be a better way, but what I did was I took all the numbers here. I saw laid out 0 through 21, and I said, what is 0 mapped to? 0 is actually the character F, L, or 1 is the character L, etc., etc. And I got that, and this is where I got the flag. And that's it. So if I were to run this program, and let me go ahead and load this input up here. So I'm going to go ahead and copy that, and then I'm going to, can you see me? And if you remember, this is the 4th argument in the program. So if I were just to give it the flag like this, I mean, you may have forgotten already, right? Because like you done all this work and you forgot that, oh snap, I got to give it 4 arguments, right? And like the first 2 do not matter. So I'm gonna just give it 1, and then bam, good job, we got it. And that was an experience. And I'm gonna show you what I was confused about is when I looked at this. When I looked, I mean, I got the random part. That was easy, but I was confused about why it was getting the it was doing the stir length of this thing here. I was confused about what this actually was, because when I looked at it, I was thinking, okay, maybe this is gonna give us 88. Cause I for some reason I thought Xflag was its own string, right? But it's actually, I guess it's an array of strings. I guess that's what it is, right? I'm not sure how to describe it, because I'm still kind of baffled about what the author was doing, but it was interesting. And you know, I didn't understand why. Like, so I'll show you an example really quickly here. Is it still in my? Yes, it is. All right, so I'm gonna run this in GDB, and this is where I really got lost. I'm gonna disassemble main, and I'm gonna tell it to break here, and I'm gonna run this with 1 in our flag, just so it's easy. All right, so I was able to follow along, so I said, okay, I understand how it returns 8. I get that, and then you know, I followed all this stuff. I said it's gonna check if it's 0, it's gonna set that to 1, and then it's gonna get our user input, subround the number, right? It's gonna put D in there, hex 64, and then what it's gonna do is it's going to load up our Xflag sub I. And this is where, for some reason, I was just so confused. I didn't understand why when this returns here, you see here it's 8048630. It didn't click that was the string. I was just so lost. Like, where is it getting this address from? And then I was thinking, like, okay, well, it should, like, when this returns, EAX should hold. I was thinking like 88 or something like that, because you saw, and if I go to Xflag here, it was size 88. So I was thinking, okay, it should be 88 or something. But when I ran it, it said, next over this, it said hex 64. I'm like, what? Where is it getting that from? I'm telling you, I was lost. And eventually, it just sort of clicked. Like, I think what it made it click for me was when I clicked on this. I was like, oh wait, hold on, wait, 8048630. I double clicked and I was like, oh wait, this is a bunch of spaces. And I saw, oh wait, hold on, there's actually some no characters here, right? If I can find them. Where are they at? They're somewhere on here. I showed them to you earlier. There's some no characters there. And I was like, oh wait, so maybe this is a string that has a whole bunch of spaces in it, and they're getting the length of that corresponds to a letter. So essentially they transferred the flag into spaces. I was like, man, that is some clever stuff. I was impressed. I was like, wow, that's crazy. I mean, maybe I'm easily impressed, but I thought that was pretty cool. And like I'm telling you, it threw me for a loop, but I was able to eventually get it. Took a lot of debugging, a lot of like just kind of running through and just making sense of it. And I even wrote my own little program that did something similar to confirm that's what the author did. And yeah, that's what the author did. And so that's pretty much it for this one, everybody. If you enjoyed this video and learned something new, give me a like. I really appreciate that. If you have any questions, comments, concerns, I know I may have explained things not that good this time. So if you have any questions, please, the comment section is always open, and I'll be in there all day, every day. Well, not all day, but I'll be in there. Okay, I will respond. And of course, if you like this video and you see more of this type of content, do not forget to subscribe and hit that bell icon so you're notified when new videos go live. See you guys in the next one. Peace out. Hey, what's going on, you guys? I actually forgot that I didn't tell you guys my theory about why I think it's using this really big number here, hex 2196AD, A60. And the reason why I'm gonna say this is a theory because when I tested it, it didn't quite work out the way I was expecting. But I think what the author did was something along the lines of like Sterling of Xflag, and maybe and the reason I'll say it's a theory is because it didn't quite work when I tried to like I think I mentioned in the video that I actually created a string of size whatever, and I had like all the spaces in there. I pretty much recreated this string there, but for some reason when I get the length of it, it doesn't give me what I was expecting. It doesn't give me that really big number. And so again, I'm not entirely sure what the author did, how he got that big number. Maybe he just chose a huge number, but I don't think so. But anyways, yeah, that was it. By the way, this mouse right here is trash. Okay, I don't know if you can see it, but this is trash. Do not buy this crap. Please give me a suggestion on the mouse. I said that in the video. Like I think I put it like in the text. Please, I need something because this right here is not cutting it. Like y'all saw the trouble I was going through. I actually had to switch my trackpad midway through the video. That's how bad it was. So please give me a suggestion on the mouse. I prefer it to be wireless and maybe one that has like the little USB, but anything, anything. All right, see y'all next one. Peace out for real this time.